All right, so you should have downloaded, installed, hopefully launched Unity at this point, but we'll go through some of these steps. Also, just to make a note here, let's see. We're going to go pretty fast. I am going to pause here and there and talk to you a bit and ask you some questions. But hang on tight. Don't get bogged down with what I'm doing or what you're doing. Try to just keep up with where we're going. It's okay if you don't get everything. That's what the recording is for. But this is going to help you, especially if you put your hands on it. So follow along. And if you're way in the back, coming closer may be helpful because I think this is the only screen we got here. All right.
So way back, we've got Learning Fellows who are welcome to come closer.
Okay.
But that last table, guys, can you see well enough?
Cool. All right.
Ben? Sure.
So yeah, I can't cover everything, of course. You should expect that. There are going to be things that I have to skip or things that I'm going to alter as we go through it. So kind of use this presentation as a springboard. Think of it as like plugging some of the gaps. If you've explored Unity yourself a little bit, I'm going to just lay the base down so that you can make sure you know where everything is. And then that'll help you find other resources that are useful to you. Most of the things you'll find on YouTube will be right at your level. You'll understand them. All right, so I want to create a new project. When you launch Unity, it's going to launch the Unity Hub, which is just a manager for your installations of Unity. You can see I have I have 4 because I uninstalled like 5 other ones. But I'm probably just going to use this version of Unity, the latest one that I have installed. As far as the things that we're going to be doing today, it'll work on any version of Unity in the past like 5 years. So it really doesn't matter which version you use right now.
Can I ask one question? I was thinking, what's the relationship between the Unity editor and a Visual Studio? I saw yesterday Visual Studio pop up, but they know Visual Studio quite well. So
yep. So yeah, Unity itself is a fully featured game engine and editor built into one package, one program. It needs to reference code because there is scripting support in Unity. We do our scripting in C#, though it does support some other languages. The connection to Visual Studio is that Visual Studio on Windows is the recommended IDE, Integrated Development Environment, to use with Unity. So Unity comes prepackaged with a connection it can make to Visual Studio. You usually do want to install both of them together. And that makes it a lot easier to work with your code. You can just, when you open up a script in Unity, it actually launches Visual Studio. That's what we'll see. And you can also do debugging from Visual Studio. You can set breakpoints and step through your code as it runs in Unity. So it's a really nice thing. You can adjust those settings, so you could use a different code editor if you wanted to, but that's the one I'm using. All right, so let's make a new project. I'll just use this latest one. All right, so I'm going to just name this Unity Crash Course. And I want a place for it to be stored. So if I go look through my stuff, I mean, I could find a nice place, just a random folder or whatever. But what would make a lot more sense is to use this as a rule of thumb. Whenever you're creating a new Unity project, think first about how it's going to be stored in version control. It's sort of something you should get used to, putting all of your code in version control, so that you always have a history to look at. You can make changes and not lose progress and all that stuff. So I'm not yet ready to just choose where it's going to be. I've got to set that up. If you go to like, you can use any host you want, but I'm using GitLab. It's very similar to GitHub. And so I've set up this new project here, and I'm just going to clone this before I create my Unity project. So here we go. Just got to find a nice place to clone this. All right. So I've got a new directory here. This is what I'm going to use. So I can now choose that. Go find that. And that sounds cool. All right, so this will take a couple minutes for Unity to create this project and set everything up and compile its scripts initially for my project. But I've seen that it's already created this folder for me, which is great, because then I can jump in and do the rest of my setup for Git. Unity does create a whole lot of temporary files, a lot of extra things that we really don't want to check into version control. It's just going to bloat our repository for no reason. So we can just look for, do you like my background? My son did that to me, so I just left it.
How old is he?
He's, let's see, he's 12, 10, 11, somewhere around there, one of those numbers. Let's see, Git Ignore. All right, so if you look for Unity Git Ignore, GitHub has a repository that has a bunch of sample Git Ignore files, and this one works pretty well for us. I'm just going to download this file. Let's see, store it in my project folder, and the naming is important. It should be just .gitignore so that Git recognizes it. All right, so Unity's still churning away, trying to set up my project.
Sorry, where did you store that?
I stored this Git Ignore file in the project directory of my new Unity project. So there are some Git Ignore files that are set up where you can just drop them into the root directory of your repository and they affect everything. This one's specific, you can tell with these slashes on the side. These are specific to local directories relative to this Git Ignore file. So that's why you have to put it in here. Yep, so what that will do is make sure that temporary things like practically everything in this library folder are going to be ignored and not be checked into version control. If they change, I don't care. Okay, so overall, we'll get into like working with Unity, but it's important to understand sort of the philosophy of how Unity works with the world that you're building. Oh no. Let's see. I think I'll try that. All right, yeah, I had this problem once before with, yeah, I'll just try opening it again. So yeah, Unity's philosophy, the way that they designed and architected the game engine, is that it's really built around game objects. There's a concept called a game object, and you can think of it as a kind of thing, like a placeholder in the world, and it's really like a container for behaviors. And those behaviors are given to us by components. So you can use any sort of components, all these different pre-built like behaviors, or you can create a script, a C# script, and those can act as components as well. So when you attach them to your objects, they provide a custom behavior. So yeah, we've got game objects and we've got the components that you build into those game objects to give them their behaviors. So here we are in the editor. I'll just give you a tour of what's going on here, and we'll mess around with it as we go. In the center, we've got the scene view, which is where we do all of our 3D navigation. We get to select objects and look at them and stuff. Also, when you select them, whatever one of these primitive tools is selected, it gives you different handles, and so you can modify and mess with things by just dragging them around. There's a rotation tool, so you can like turn the view of this camera object that I've selected. There's a scaling tool, which won't do anything to my camera, but you can make things bigger or smaller. And then there's a Rect Tool, which we'll use for UI later. What's this one? Transform tool. Oh, that does multiple transforms. I don't need that. So you can find all these here. They also have key bindings like WERT. If you play a MOBA, you're going to find this very comfortable. So we want to know how to navigate around in this this area. The first thing is you can right-click and hold that button to kind of look around, move this view a little bit, and then it gives you a little indication there, that little T of keys there. Does anybody know what that represents? What do you expect those keys to be? Do you see the little T of keys there? Next to the eyeball. It's a hint.
Oh.
All right. They're WASD. So that pattern of keys on your keyboard, W, A, S, and D, are going to let you move around your world a little bit while you're holding the right-click button. You can also use the arrow keys. Not on this one. Never mind. Just W, A, S, and D. Selecting things is with left click. Middle click lets you pan around and scroll if you have a scroll wheel. And then Alt and left click is a way you can orbit the view around your scene, around objects there. All right, so that's most of what we're going to do in the scene view. The scene view also doubles. It's in the same location by default as the game view, and you can switch between these. The game view takes on the viewpoint of the main camera that's in the scene. So if I had selected that camera, I can see that view here, and that's a preview of what I'm going to get. And when you press play, when you enter playback mode, it switches right over to the game view, and this is what you see while you're playing the game. But while you're working or playing this game, you can also switch back over to the scene view, and you can mess around with stuff as the game is going. Be warned, though, you should, before you make any significant changes, stop playback mode, because playback mode is making temporary changes to your objects. Like your objects might move on their own, or you might drag them around, resize them, but once you press stop, it's going to revert those changes, most of them anyway. So just be aware, play mode can be a little bit dangerous if you think you're not in play mode and you start making a whole bunch of changes. So yeah, there is the possibility of like, you can grab these tabs and dock them, drag them into different places, and sometimes you can end up like losing some of these things, closing them, and you don't know where they went, and you're like all confused. You can just go to Window. There's a Layouts, and you can go back to Default. There's a thing up here, an easier, quicker switcher for that, but you can always find it in the window menu. All right, so you may have noticed when I was selecting this object and maybe this other object that a couple of other things happen around the screen. Over on the left-hand side, we have the hierarchy. This is a panel that is just a list of all of the objects in your scene, all of the game objects, but it's also organized hierarchically. They have parent and child relationships between objects. So if I have an object in the hierarchy, I could drop other objects onto it to make them children of that object, and then when you move around the object, it's going to affect all of its children. So let's create something. in this panel, there are a couple of ways to create new objects. You can right-click, which is my favorite way, and then you've got this create empty, you've got 3D object, which has a bunch of good options here. You got some other fun stuff. I encourage you to play with particle systems at some point. You can also find that same menu through this plus button over here. There's lots of that stuff going on. Or if you go up to game object, you can see it's like almost practically the same, right? All right, so let's right-click in here and create some object. Start off with a plane. So that's just a flat surface for us. And it doesn't necessarily get created where we want it to be. It's based on where our view is right now. So you might look over on the side in this inspector panel and notice that its position is at some weird place. So you can zero this out and kind of get it back to the center of this coordinate system. All right, let's create another object. Right-click in here and you can create a cube. And this cube also might be in a weird place, but yeah, there it is over there. So let's try centering it. Okay, so it doesn't look a whole lot like a cube when I'm looking at it here. What's going on here? Yeah, it's sort of, its center point is where this position is referring to, right? So it's right in the middle of the plane. We got to like lift it up a bit. So notice as I lift it up, what axis was changing? What was I actually modifying there? The y-axis. Is that normal? Is that what you expect from like a math class? Maybe. Did I go to a different kind of school than you? So yeah, normally to me in a math class, use z as your vertical upward axis. Y, the xy plane is that flat thing that we do in 2D, and then the extra one was z going upward. So in Unity's case, and you can tell by looking at this gizmo here for just moving the object, or you can look in the corner, there's an indicator showing you those axes, that yeah, it really does have y as upward. So just something to remember. Conventionally in Unity, we treat positive z as the forward direction, positive x as your right, and positive y as up. And one weird thing, if you care about mathematics, that this actually does, just swapping the z and the y, it means that this coordinate system is left-handed. And if that means something to you, you get a left-handed thumbs up. All right, so I know that I recognize that this is kind of close to sitting on the surface here. And I can tell that it's probably 0.5. So the height of this object is 1 unit, right? Units aren't explicitly specified in Unity, but we do have an idea that 1 unit roughly equals a meter. So think of it that way if you're trying to like space things out, get things like to the right scale so that they all make sense together, doorways and stuff. 1 meter is roughly 3 feet, so 2 meters is about the height of a human. Let me get that. I need to close this. Where is that? I can't even tell. Where's my mail? I don't know. I'm gonna have to leave it. Maybe it's this. Okay. Anyway, so 2 units high is roughly the height of a human. So if you were like going through doorways and stuff, that's kind of the what you want to aim for. Okay, cool. So like I was saying, when you select this object, you can mess around with its properties on the side. The inspector panel lists out all of the different components that are attached to this object and provide its behavior. every game object, even empty ones, so if I go over here and I create an empty game object, every game object comes with a transform component. This is going to provide its position, its rotation, its scale, just kind of the basic orientation and positioning in 3D space. This is useful for us, and it also means that when we're working with a game object, we can assume that it has a transform component, which is nice. We work in 3D space all the time in Unity, so it just makes sense that way. So I had said that you can see hierarchical, like parent-child relationships in the hierarchy. So you can do things like, here is a sphere, and there it is. And so you can grab that sphere and give it the cube as a parent, and then when I move the cube, the other one follows with it. So this is something you can do for certain things. You can do like really simple parenting arrangement. You can say like the main camera could be a child of the cube, and then suddenly you've got like a follow cam. A really bad follow cam is not really recommended, but it's possible. So let me drag that out and make it its own thing again. All right. So let's take a look further on some of these things that the cube comes with. The cube comes with a mesh filter component, which is really just a reference, a placeholder for it to refer to a specific three-dimensional mesh. Then you've got a mesh renderer that's using that mesh filter component and making an actual visualization or rendering of that. And then the box collider here is a separate shape that determines the collision boundaries for the physics engine. All right? And then down at the bottom, we have add component, which is how we can add additional behaviors and properties to this object. So coming along down to the bottom, we have the project panel. And the project panel is where we store all of our assets. Whenever you need to refer to any sort of file, anything that is contributing to your project but isn't necessarily in the scene, it can be like sound files, it can be textures, it can be 3D models, it can be all that stuff. Everything that's a part of your project could be in any sort of level, even the levels themselves, called scenes, are files in your assets. So this is where those things are going to go. One of my favorite assets that we can create is a script. So let's create one of those. If you right-click down here in the project panel, go up to Create, and there's a C# option here, C# script, among many options. We can create a new script and give it a name that actually means something, like player controller. And then maybe our cube is our player, so I'll just rename it player. Okay. So when you've created one of these scripts, it's important that you rename it right away. You give it a name, just because it'll make your life easier. You can see on the side here, this is a preview of what the file looks like, and Unity generates some boilerplate code for you so you can just jump in and get started with it. And part of that is naming the class in this file. So it's named the same thing that you type for the name of the file. And because of that, you should avoid putting spaces in there and stuff. Just make it a valid identifier in C#. And then we can attach it to an object. Let's say our player object. One way is to just grab that script and drop it in here. Another way, you can click on the add component and you can say player controller. You can find that, that script that way as well. So once we've got it attached, we're cool to start editing it. You can double click on it in here. There's that script field there, or you can double click on it in your project panel. how's it going? Any questions so far? Everything pretty cool? Okay. So our player controller is going to be a component. And to do that, it needs to inherit from this special class that Unity provides, MonoBehavior. It's got a U because early on in Unity's development, some British person was involved, I guess. This is, if you're familiar with inheritance, and hopefully you should be, inheriting from MonoBehavior means that a player controller is a MonoBehavior, and it inherits all of the properties of the MonoBehavior, all of the public, private, protected properties. So MonoBehavior provides kind of the basis for Unity to recognize this as a component, something that can be attached to objects and something you can interact with, and it comes along with some expectations. So Unity has filled in for us some starter code here. We've got a start method and an update method, and these are really treated as events. Unity knows when an object is created, and so it will call the start method of each of its components. It knows when, Unity knows when a frame is completed, and every frame is going to call the update function for all of the components attached to your objects. So these are two really, really handy, useful things. If we wanted to do something to set up our object, then we can do that in the start function. If we want to do something every frame, we do it in update. You may be familiar with classes in C# where you would normally use a constructor to set up the object, to initialize it. But if you're inheriting from MonoBehavior, you should be doing that work in start for the most part. That's just what Unity is going to call to make sure that your object is set up. You are not responsible for creating these objects directly. I'm never going to use like the new keyword to create a player controller, and that's why we do our initialization here. There is another function that's related to start, and if you start typing it in, it'll probably give you a suggestion. Awake. So start happens, as it says, before the first frame update. So everything gets set up, Unity loads up everything, and then calls the start function on all of these components, so they all get a chance to set themselves up. But at that point, you might end up with a case where objects depend on one another, and their start functions might be called in a different order than you expect. So if you need stuff to get set up before the start function, you can use awake. So that's all that is for. All right, so let's do something like maybe change the position of this object, which is probably a bad thing to do in start. So we have access to our transform component pretty easily through MonoBehavior. It has just transform dot, and then we can access all the things that a transform is capable of, this object's transform. So you can see that transforms are the object that's responsible for keeping track of child and parent relationships. There is a bunch of other things in here that we can do with it. But the ones that we want are those position, rotation, and scale things. So let me do position. And I want to change this position. If you hover over position, it's going to tell you that this is a C# property that gives you a vector 3. Position is a 3-dimensional vector. So this is a vector 3 in the sense of your math classes, X, Y, Z. And so when we want to replace our position and give it a new position, we'll just create a new vector 3 and give it some coordinates. Let's say 1, 4, 2, I guess. Just arbitrary stuff. and then we can try this out. Let's make sure it's all good. Okay, so I started running my game, and this object like jumped right up there. So that's its starting position now. That's not always the most useful thing to do, because what if my designer is like, I want this guy to start over here, and then I press play and it just completely overrides that and throws him up in the sky. That's not usually a good idea, but it gives you a sense of what we can do to set things up in the start function. I'm going to take this though, move it into my update function instead. So update is called once per frame. How many frames does a typical game render every second? 60, yeah, usually. And that's because it's synchronized with the refresh rate of most standard monitors. 60 hertz is typical. So we can expect that 60 frames per second is our goal. It's what we usually get. And so when we are using update, we have to be conscious of the fact that this is happening 60 times a second, right? So let me try to move this object. Since I didn't I didn't override its starting position, I'm gonna take its position and add to it instead. Let's do a plus equals. And let's just move in the X direction. Does that sound good? All right, let me move it back to the center and try this out. It's gone. That was quick. All right, so what's wrong here? That was very fast, but I just put 1.
That's on the update, so every frame is moving one unit per unit?
Yeah, like 1 meter, right? So yeah, every frame, I mean 60 times a second. It's actually moving 60 meters per second, which is quite fast. Yeah.
So is the space that it's moving within infinite? So does that mean that while you leave it running, it's still moving?
Yep. It'll keep going as far as it can within like floating point precision. So yeah.
That's what we talked about, where it's very happy to draw your square or whatever up in the ceiling, because it doesn't care.
Yeah, so this is happening 60 times a second, 60 meters per second. Sounds awful. That's something like 100 miles per hour. I don't think that's what I actually intended. So what we want to do then is take into account that what we're actually doing is taking our position and trying to change it just a little bit each frame. We're trying to achieve something that's like persistence of vision, if you're familiar with that term. Something that fools people into thinking that motion is actually happening. It's a dirty secret of the games industry. It's all fake. It's a lie. So anyway, we've got to pretend that this thing is moving by just changing its position every frame. And we want to do that just a little bit. We're really integrating the position. And if you've taken calculus, this might mean something to you. We want to take a little slice of its velocity and add that to its position. And then next frame, take a little slice of its velocity and add that into its position, and keep doing that to kind of integrate its position over time. So here, I want to take my velocity, which is this thing on the right here, and I want to multiply by something that's a thin slice of time. Time.delta time will give us the amount of time it's taken for one frame to complete, like the last frame. And by multiplying by that, it's going to effectively convert my units here from meters per frame to meters per second. Yeah, so this is going to be a lot nicer, I think. Let's save that and double check. Okay, yeah, that's much better. All right, way more reasonable. Still a bit slow, but we'll see about that. Okay, so great, we can move in one direction. What we usually do, though, for a player is to actually control it with user input. So here, I'm going to show you kind of the older way to do user input, just because it's a lot easier to get into. When we do it all through this input object, you can do input dot, and you can see that there are tons of options for us for what we can do with the input that Unity is measuring and pulling for. So input dot, let's see, we've got down here, there's a good group of them. There's get axis, so we can ask it for a specific named axis, left and right, up and down, that kind of thing. There's get button, so we can find out if a button is being held right now. But there's also two other get button functions here. Get button down, get button up. And these ones should make some sense. Get button down is going to be true when the button has been pressed. And it only lasts for one frame, which is really convenient for us. It gets reset every frame. So get button down will tell us, you pressed a button. Let's do something about it. Get button up is going to tell you that you've released a button this frame. So get button is the one we want to use if we want to know if the button is currently being held. So it depends on which kind of game you're making, what you want to use. But say you want a game that's like on a grid, and every time you press the key, you want to move over one spot. That's pretty typical for those kinds of games. But if you want something that happens smoothly and constantly, you'd be using get button or get axis to tell you to move to a different location. All right, so let's try out get axis. Get axis is a function, and it takes an axis name as a string. So there are some magical strings here. This one I'm going to use horizontal, and this function returns a floating point number. So let me catch this in a floating point variable. So this special this special name of this axis is one that's already mapped for you. We can go and we'll find where this is, and we can look at the mappings that already exist, and you can modify them there. But I'm going to use the one that's built in because it is automatically mapped to WASD and the arrow keys as well. So let me get the vertical axis as well. All right, so if I were to use these get axis things are going to give me like, let's say on the horizontal axis, I'm pressing left and right arrow keys. Left arrow key is going to give me -1 to tell me it's going left, or right arrow key is going to give me +1 so that I know I should be going to the right, or if I'm not pressing either of them, it's going to be 0. So where should I put these? Which axes do we want to move on? There's X, Y, and Z as options for you. All right, let's try X. Yeah, that's good. Let's put horizontal here. All right, what's next?
Z.
Z? Why Z?
Because isn't Y going up and down?
Yeah, so unless you want me to like fly and stuff, I mean, that's cool, but yeah, I want to run around on this plane. So Z is the appropriate axis here. It's going to be the XZ plane. Okay, so that looks pretty good. Let's try it out again. Nice. Nice and slow. Okay. I can also just run right off of the plane because there's nothing telling me to fall. There's no collision going on. All right, that's cool. So now if I want to like control the speed here, what I should be doing is thinking about it in terms of vectors. I've got this velocity vector, and I have a direction for it according to horiz and vert. And I want to control like the amplitude of that vector, the magnitude of that vector. And I can scale this vector just by multiplying. So if I have some number, I can multiply this vector by that number and change my speed. So let's do it here. Let's make a variable speed. Let's do like 10. All right, throw that in there. So now I'm multiplying by my speed. This should be 10 times faster. And to give me a better view here, I'm gonna take my camera and just lift it up a bit. There's a cool thing I can show you here too. Like lifting my camera, I could rotate it and stuff. But if I want to find like a nice view using my viewport here, I can go in here, find a good spot. This looks nice. And then if you have your main camera selected, or really any object, but cameras work best for this, select the camera, go to Game Object, and then Align with View. We'll move it to the place where you currently are in the scene view. So that's a nice handy way to get the positioning right for your camera. Let's try this out. Should be a little bit faster. Yeah, that feels pretty good. Nice. So there is a detail here. I can tell a few details. So notice this. If I'm just like tapping my button, or if I release my button, you notice something? There's a little bit of momentum there. And this isn't a physical momentum. This is actually a smoothing that's applied to the input itself. So when I press A, it's either up or it's down. It's either a 1 or a 0, right? And Unity, though, wants to make it a little bit smoother and nicer. You can change how that works, but by default it smooths those inputs so that when I press A to start off with, or D, it doesn't immediately go straight to 1. It ramps up a bit. And so that gives us just a smoother motion to start off. And then when I let go, it doesn't go straight down to 0. When I release it, it smoothly drops down to 0. So sometimes that's what you want, sometimes you don't. But be aware that that is a thing Unity does. So yeah, there is that. There's another thing here. Let me wander around on this thing. All right, so I'm going left and right. My speed is 10, right? So 10 meters per second if I were holding left or right. And then up and down, also 10. Why do I feel so fast going diagonal? It's a combination of them, right? It's a combination of the other ones because I'm telling it to. Like, this is exactly what I told the code to do. Horizontal could be 1, vertical could also be 1. This means that, and you might have seen this in some games, where you move faster diagonally than you do left and right, up and down. Yeah, do you have a comment?
Yeah, if you hold really any of the movement keys and then you hit the opposite of the movement keys, so like B and A, you stop its momentum completely?
You mean like immediately?
Yeah.
Doing
like a counter trade.
With how we currently have it?
Yeah, just out of curiosity.
I'm not sure.
Because I'm sure that there's
I
a way to
yeah, I feel like it still is going to not be an instant turnaround. But yeah. Yeah.
There was something I noticed in the 2D editor. You were on just like the blank plane, and if you spam A and B back and forth really fast, it would quickly build up momentum, and then if you let go of one, it would fly across the screen.
That's cool. Yeah, that probably depends on how it's scripted. Okay, so what we can do here is recognize that what we actually want to do is get a direction vector for our velocity and combine it with our speed. Doing this with our horiz and vert is making it so that our vector is not always normalized. It's not always a length 1 vector. So I'm going to make a new vector here, vector 3. Let's call it direction. And we'll take this here. Yeah, like that. And then we can do direction.normalize. And then we avoid that whole problem. If these are both 1, then doing a Pythagorean theorem of combining these things is going to give us like 0.707 for each of these instead. And that's going to mean when we multiply by our actual speed is going to end up being 10 instead of over 10. Make sense? Is that cool? All right. So another thing here, we have this speed of 10. And if I wanted a different speed, I could change it here. But if I have someone else working on my project, I don't necessarily want them having to dig through code to go and change these numbers, right? So there's a better place to put this in order to make it accessible to like game designers. I'm going to take this variable and move it up into the class scope right up here. So what you can do, one way is to make this a public member variable. And the public access specifier, if you're used to this through inheritance, public is going to make this available to other things outside of this class, other classes. It also exposes it to Unity. Unity is going to be able to see this variable and it recognizes that. So if I go back to the editor and select our player object, you can see there, we've got a speed variable now in this script component, and we can just modify it. I thought that was too fast. And that'll be used when we run and play it. So this is one way that you can expose variables. Sometimes, though, you don't want other classes like poking around and having even the ability to change the speed of your player controller for whatever reason. So I'd really prefer this to be a private variable so that other scripts don't have access to it. But that means that Unity also can't see it. We will have to specifically call this out. There's a special attribute we can use, serialize field, in square brackets here.
Is there no protected, or that would not?
There is
right?
protected. Protected would be fine if you intend to inherit from this.
But it doesn't give you up, you need to see it up, right? Unity needs to see it.
Unity would still not be able to see protected fields, yeah. So yeah, I'm just going to set this as private and use this attribute instead, serialize field, which will allow the Unity editor to see it, but all other scripts are still, it's still private to them. All right, looks pretty good. Excellent. Okay, so there are a couple of very common components. Let's make another object in here. Let's see, a 3D object, let's make it a sphere. I'm going to call it ball. All right, so we've talked about some of the components that come by default on some of these objects, but there are common ones like rigid body. So if you go to select the ball, add component, and start typing rigid body, you can find the rigid body component. There's also one for 2D games, but we'll be using the normal 3D one. And when you add that, rigid body is a connection to the physics engine. It's going to give this object a built-in velocity, a mass, and so on, and a way for other objects to interact with it by physical collisions. So by adding a rigid body component, you can also see that there's a use gravity checkbox here. And so when I press play, gravity. It fell. We can also, you know, kind of bump around with it a little bit, but it's not detecting our collisions all that well because the object here that's moving is does not have a rigid body component. It's not expected to move. It's more like a static object, but we're forcing it to move. So what we couldn't do too is add a rigid body component onto our player object. Use gravity, that's fine. I'll just fall off the edge. And let me also expand my playing area here. So I'll just scale up our plane. Okay, cool. So you can see now my objects are interacting physically. They're bumping into each other. And that's causing some rotation on my player. So depending on what you want to do with this, like that might be fine. But you're also imparting a velocity to this player object. That may or may not be what you want. So let's say you wanted to lock that rotation. This rigid body component has a constraints section where you can expand that and you can freeze rotation so that physical collisions don't affect your rotations. Let's say like I don't want to get knocked over, so I can freeze the x-axis and freeze the rotation around the z-axis over here so that I won't get toppled by an object. Leaving the y-axis free will still allow my character to rotate about that axis, spin that way. So depending on what you're going for, you'll want to make some choices like that. Or you might leave them all free, you know, whatever you're going for. All right, so in just a few minutes, I want to take like a little break, but I think we've gotten pretty far with this. The next thing we can do is sort of set up an interaction between these objects that is scriptable. So one of the things these guys can do is run into each other, bump into each other. And so we want a way to be able to detect that. In our script, if you have an object that has a rigid body component attached to it, Unity will also notify it of collisions. And it does that through a special function on collision enter. So there it is. You can also see, if you just type on, there are a bunch of these other events that are possible depending on what kind of, how you've set up this object. But I want on collision enter. And so on collision enter is going to be triggered whenever we bump into something. And so here's a collision object that's given as input that gives us information about that collision, what objects are involved, like how fast the collision was, that sort of thing, where the collision point is. So we can do like collision dot, and we can see some things about this, right? And the most useful one here is collider. Collision.collider is that other object. It's the other object's collider component. It's what we've run into. And so we can do stuff with that object. Let's say this. There is a function we can use to just print out some debugging information. Just give us a message. Debug.log. So debug.log accepts a string, and this is a good way to make sure that things are happening the way you expect. So I'll say collided. There we are. So whenever this thing gets triggered, it's going to say collided. Okay. So nothing seems really obvious to me. But if you look carefully, down here at the bottom, there's a message, collided, the one that we had created. If you click on that message, or if you click up on the console tab here to get to the console panel, it will show you all of the messages that are being put out by this debug.log. So every time that I touch this thing, we've got collided. I think I'll probably collide with the, oh, okay, I fell off. It'll also register collisions with all other objects. So even just dropping onto the surface here gives me a collided message. So I want to be a little more discriminate with what I'm actually colliding with. Let's see. So maybe I want something special to happen if I hit the ball or if I touch a certain object. I'll just use this message for now. So if I wanted to see, all right, what object is this, or is this a specific special object, then I want to use Unity's tag system. Up here in the inspector, you can see there's a field for tag. It is currently untagged. And if you click on that, you have some options for different tags. One of them is player. Hey, I might as well tag the player as a player. That's cool. And if you go to the ball, of course, there is no ball tag. So I'm going to have to create one myself. So let me add tag. And so add tag gives us the tags and layers menu, where we can see that there are no custom tags in this game. So I'll press plus to add a new tag and just call this ball. So creating tags in this panel doesn't actually apply the tag to any object. You have to go back to the ball and say, all right, you are being tagged as a ball. And so tags are kind of like a way of categorizing objects. Sometimes you'll only use a tag for one special object, but sometimes you'll use a tag, like if I had multiple of these ball objects in the scene, then I could use a tag, the same tag for all of them. It would be fine. All right, so now with a tag, I can say, all right, on collision enter, I can say, use this collider component from the other object and do dot compare tag. Let's do ball. So compare tag is going to give us a Boolean, a true or false, which means it works great for conditionals, if statements. So if it is a ball, then I will say collided. All right. Seem pretty good? So now we should be able to test this out, make sure it all works as expected. And then we have collisions with the ball. One thing that we could do, like reacting to a collision with the ball, maybe you get points for ramming into the ball, or maybe you could cause the ball to get pushed even harder than a normal collision would give it, like give it a kick. Or we could destroy the ball, or any sort of thing you would want to do, we can do in response to this collision event. So one thing I might want to do is take this idea and apply it to maybe like a goal zone or something. Something that you can't really collide with, but we want to detect if the ball has entered that zone, that volume. So here in the editor, I can create a new object. Let's create a new 3D object, cube. Oops, I did it again. Let's call this goal zone. And make sure, yeah, let's put it over here, make it hard. And I will scale this up a little bit. Cool. All right, here's our goal zone. The goal zone, though, is really just another object. It's something I can bump into. That's not quite what I want. I don't want a wall. So I'm going to choose this is trigger right here in the box collider. I can check that. So isTrigger is going to change this volume into a trigger volume, one that doesn't actually collide with anything. The collider then is being used to detect when something enters those bounds, and it's going to instead of triggering the on collision enter event, is going to be triggering on trigger enter event. So let me add a component here so that I can respond to that event. Let me just create another script. Let's create C# script goal. Put that onto our goal zone. Okay. All right. So now we've got this. The goal itself, all I want it to do is respond to things entering its trigger volume. So on trigger enter. You'll see other functions that are related, just like with on collision enter. There's on collision exit or on trigger exit when they leave contact with each other, and on trigger stay and on collision stay that keep happening every frame that they are currently overlapping with each other. All right, so let's do on trigger enter. Check to see if the other .compare tag is a ball, and then say something. Okay, that sounds nice. But really, this is a debugging message, so this is just for me, the developer. We should maybe later make something the player can see. Okay, so this should work fine. One thing I should point out here is that in this on trigger enter, the input is a little bit different. It's not giving us a collision object, it's giving us just the collider. It's telling us that this thing has now entered the zone. It doesn't give us any information about a potential collision because there isn't one. So contrast that with on collision enter, where we're given a collision object, and from there we have to get the collider. All right, let's check this out. Make sure that it works as we expect it to, and that I didn't do something dumb. Okay, let's go try to get this ball in the goal. Go ball, get to the goal. It's going, it's going. Yeah! All right, got it. Nice. All right, so that's a good place to hang out a bit. So let's take a little break, let's say 10 minutes, and come back afterward and keep going with this. Sound good?
It's weird, honestly, but I'm starting to understand.
Okay, that's been a lot of minutes, right?
I think so.
Okay, so ready to get rolling again?
GitHub's working pretty well right now, I think. I actually understand it after working.
All right, so far we have gone through just the basics. From the ground up, let's get into Unity, let's see what it's about. Here, in this second half, I want to kind of dive into some more behaviors, some things that are common to games, maybe will be helpful for you in your projects. And you can always take pieces of these things and not other pieces, totally fine. So the first thing I want to do is kind of spice up what we've got here visually. It's kind of hard to play with a game that everything is white. So let's import some assets. You can normally just drop things into your project folder here, either this project panel or in the file system itself in your assets folder. But you can also access the asset store The asset store is recently moved. If you go to Window, Asset Store, it tells you. Wow, all right. So let's go online. Let's look at the asset store. There is an asset, an older asset, called Standard Assets. I'll just type it in for your benefit. Search for that and we'll just import this thing. You'll find it. It looks like, like a plastic model in the sprue. Click on that. Okay, so you might have to log in. I don't know how that works, but you might have to set up a Unity account and so that it keeps track of the assets that you've bought and that you have access to. This one's free, so you should be able to download it and open it up in Unity. At least it will open up the package manager and point at that particular asset. So we have standard assets, and this is for an older version of Unity, so we might have to deal with that. And then down in the corner, you should be able to download it if you haven't already and import it. When you click on import, should pop up the import package dialog, which will give you information about what kinds of things are going to be imported from this package. So here you can see it's a ton of stuff. It's a whole lot of things. Most of it is not going to be useful to us in the least, but I'm still going to import it all because I don't feel like going through and removing things. So it's all checked. I'm going to press import, and this may take a bit. May take a little bit. We'll see. Yeah. So I'm going to use this and look through some of the assets so that we can just make our thing look a little better for now. There are a couple of other things I want to do before our time is up, and we've only have like an hour left. So we do want to get into talking about UI, user interface, putting some of that together. Hopefully we can get through all of that because that can be a very useful thing to be able to make like a main menu or something. So I'll probably skip some of the other stuff that we could do and focus more on that. All right, so this is imported, right? Yeah. Sometimes you might get an error. Let me see, did I get an error? Oh, there it is. Yep. All right, so I did get an error importing this, and this is because this is an older package. It says assets/standard assets, utility simple. All right, some script file. There's a compile error. GUI text is obsolete. GUI text has been removed. Use UI.text instead. All right, so let's go over there. Double click on the error message, and it should let you hop over to that script in Visual Studio. And so this is the offender right here. It's using this GUI text type that does not exist anymore. So what I'm going to do is change this to just text, and I need to add a different using statement here for the Unity Engine .ui module. Okay, and that should fix that error, so we can at least just move on. Not like we're even using this script anyway, but that's how we'll fix it. All right, so happen back to Unity. That should compile. All right, there we go. Okay, let me get back to my scene view, back to my project panel. And now if I go up to assets, my base directory in the project panel, you can see that importing has brought along sample scenes, standard assets, some other stuff that I can mess around with. I also want to make sure that my stuff doesn't get all mixed in with that, so I'm going to create a new folder just to organize my scripts. So I have a scripts folder, and I can just drag these things, my scripts, in there. Unity keeps track of assets and asset references. So when you make an asset and you like attach it to an object or whatever, you can still move it around in this directory tree from within Unity, and Unity will keep track of those references and update them. You don't have to worry about moving them, breaking stuff. So then in this standard assets folder, whole bunch of options in here. You can go explore them. One that I like is if you go to characters, there's third person prefabs. So here we have a couple of third person characters. You can even like grab one, drop them into your scene. And let me choose our player, and up here there's a checkbox. I can disable the player. So that makes the player inactive. None of these components are going to run because this guy is now my player. He has a bunch of stuff built in attached to him already. So this is Ethan, and you can move him around and jump and stuff. But he can be kind of fun to play with. All right, so Unity uses this idea of prefabs, where you create an object, set it up, and then store it as an asset. And so that asset can then be reused in your scene as many times as you want. Actually, I can throw more Ethans in there. I don't want to. But yeah, let's get back down to standard assets, and let's say environment, terrain assets, and there should be some textures in here that I can just slap down there. Textures themselves, these are just, this is just a color texture. So it's meant to be the color of a surface. But when you're applying things in a 3D game engine, you really more often are working with complete materials. And so you may have noticed when I dropped that on here, it created this materials folder. And so when I select this object in here, this is a material asset. And there are a bunch of other parts of a material that make the rendering look good. And right here, I'm just using the albedo map. This is the color map using that grass texture. So this doesn't look as good as it could, but we'll live with it. All right, let's head back down. I could grab other textures and throw them on things, but this is good enough. Okay. So one of the things I'd like to do is kind of use that idea of prefabs to do something useful. A common thing in games is to be able to like shoot stuff, I guess. Have you ever played a game where you shoot stuff? All right, let me get rid of Ethan and enable this player again. Go back to this guy. So let's try shooting stuff. To shoot stuff, we need something that we are shooting with, like a projectile, a bullet or something. So let me create a bullet object over here in the hierarchy 3D object sphere. Sphere is a good shape for a bullet, I guess. And I will also scale this thing down. It's a little bit smaller. That looks pretty good. Maybe a little more. All right, there's our bullet. I don't really care about the positioning of the bullet because I don't actually want the game to start with a bullet just floating there in the air or on the ground. It's not my intention. But I'm getting this bullet all set up so that I can save it as a prefab, a prefabricated object. So all of this looks fine, but I will add a rigid body component. So this thing kind of collides with things and falls due to gravity if we want that. And it will also come with its own velocity property from the rigid body component that will carry it in a direction if we tell it to go that direction. All right, so once we've got the bullet set up, then we can grab that object from our hierarchy and drop it into the project panel, it is saving that object from our scene as a separate asset in our project. So now it's actually safe to just delete this bullet from our scene. We don't need it anymore because now we can create as many bullets as we want, just dropping them around. But what I'd prefer to do is for the player to be doing that. So let's go back into the player script. Where is it? Here it is. Player controller script. And we will make a way for us to fire projectiles. First of all, we need a reference to that bullet object because that is the thing we're going to be creating copies of. So to do that, let's make another one of these fields. I'll do the same thing I did before. Serialize field, private, and this time it's going to be a game object variable. So we'll call this bullet prefab. Okay, so game object references, they are a reference type as opposed to like floats, plain old data is a value type. Value types, you can just like store numbers in them. They don't necessarily have an identity to them, but game objects do. Game objects, because game object is a class, we are referring to a specific object using this bullet prefab variable. So bullet prefab, we're going to let the editor handle hooking that up and initializing this variable, just like we did where we could change the speed to like 7. We'll choose what the actual object is assigned here using the editor. And then in our script, we need to decide, well, when are we actually creating one of these things? Most of our input handling has been done in update. I'm going to continue to do it there. So here's a good place. Let's say if input dot, and then I can say get button down. It is a lot of fun if you just use get button, because then you can just rapid fire do it. Let's do get button because this is fun. All right, so let's do fire 1. If input.getButton fire1 is true, that means we're holding down the fire1 button, whatever that is mapped to. Then we will do something in here. The monobehavior class, since we've inherited from it, gives us access to this instantiate function. Instantiate is pretty cool. It's really just cloning an object. So I can take our bullet prefab, pass it in there. But we have to choose which version of instantiate we're using here. There are a lot of different versions of it, but the one that I find most commonly useful is this version. We have an original object that we're cloning. We have a position where it's going to start off at. That's a useful thing. And then a rotation that we have to provide. So let's say position. We can use the player's position. So this object is the player controller. So transform.position is that place where the player is. We'll use that as the starting point for this bullet. And then for rotation, rotations in Unity are done using the Quaternion type. Has anybody ever heard that word in your life? Me neither. But Quaternions are a really simple way to represent rotations. Rotations, when we talk about three-dimensional rotations in like a math class, typically we talk about like Euler angles. Has anybody come across those or know of like Leonard Euler? Anything like that? Okay.
Euler's theorem.
Euler's number, E. So yeah, Euler number or Euler angles are a way of specifying rotations. Let's see, let me comment this out so I can show you in the editor. Okay, so up here we have a rotation field for in our transform component. And if we type in something like, hey, I want to rotate 90 degrees, wow, that made a big difference. Or you can grab one of these and just start dragging it, and that gives you some control over, and you can see the actual change it has. When we are rotating like this, we're specifying in terms of rotations about these separate axes, X, Y, and Z. So a rotation about the Y-axis is going to make this thing like yaw like this. The Z-axis is, I don't know, do a barrel roll or something. And then the X-axis is more like, well, let me fix all these. If I'm looking that direction, there we go. So that's like pitching. So those are useful things and useful ideas intuitively when we're talking about rotation. But there are some issues with Euler angles. There are some situations you can get into where just based on a couple of rotations, you can get these axes to align with each other, and you end up losing the ability to rotate in 3 dimensions because 2 of your rotation axes are on top of each other. That's a situation called gimbal lock, and if you are like an aeronautical engineer, that you care a lot about avoiding that. So quaternions are a way of representing rotations a little bit differently. Still, it's pretty efficient. With Euler angles, you'd be storing 3 components, X, Y, and Z. With a quaternion, you just need a 4th component. But don't think that a quaternion is just a 4-dimensional vector. It is very different from that. It is its own mathematical object. But it can be converted to and from things like a matrix to do transformations on objects. So anyway, just keep in mind that while you can specify Euler angles, Unity under the hood is expecting to be working with quaternions. Nicely though, Unity provides all the tools we need to work with quaternions. So in this case, if I am doing a rotation for a new bullet, I could do quaternion.identity, which will mean just no rotation. It's just pointing straight forward the way that it's normally. That's totally fine. There are some other options, but I could take the rotation of this guy, the player object, transform.rotation. And so wherever this guy is facing, that's also the facing that the bullet is going to get. For me, it really doesn't matter because my bullet is a sphere. But if you had a shaped bullet, then it would matter. All right, so we can try to use this now. Fire 1, yeah, that's fine. Okay, let's try it. Oh no. So Fire 1 is mapped to the left mouse click by default. That's one of the buttons. But what I'm getting instead is an error down here. Check this one out. Unassigned reference exception. The variable bullet prefab of player controller has not been assigned. This is a pretty common error, and this one is telling me that I forgot to assign that bullet prefab to some value. It's practically null to start off with. So selecting the player, if you go look at the player controller script, the bullet prefab field says none. So I need to grab a bullet. Let's grab the prefab, drop it into that slot there. You can also use the circle selector on the side here to go through. Oh man, there's tons of them now that I imported the standard assets. But you can also find your objects that way. All right, so this is a little better. Okay, oh my goodness. Let me reset that. All right, so just for a sec, let's remember what we're doing. When I click, I'm going to be instantiating these projectiles, these balls. And I did use get button which means holding it down for any amount of time. Every frame that I have the button held down is going to create one of these. Okay, so I have to click pretty quickly. All right, this doesn't look like what I wanted. What's happening here? Ship it, right? All right, there are a few issues. Can you name a few? One of them? What's going on?
Bullets have collision with the player.
Bullets have collision with the player. We are spawning these bullets inside the player, and they collide with the player, which means the physics engine has to do its very best to figure out how to get them out of collision, and that means pushing the player out of the way, pushing the projectile out of the way, and that happens. All right, so let's go through and disable collisions between the projectiles and the player. All right, so we know that the tag system can tell us something about these objects. There's another one that interacts directly with the physics engine, and that's layers. So here I have the player on the default layer, and if you look at the bullet is also on the default layer. So what we should do is put them on separate layers. These are physics interaction layers, and we can then tell those layers not to interact with each other, and the physics engine will just ignore them, those collisions. So if you pull down that layer and add layer, brings you to this very familiar screen where we had tags, but now we have layers we can type in. All right, so let's say we have the player layer and let's call it a player projectile layer. All right, player and player projectile. Then when we select our player, let's throw the player layer on there. And then for our bullet, this bullet prefab, we'll put that on the player projectile layer. So every new bullet is going to be on that layer. Okay, and then to make those layers interact the way we want them to, we can go to Edit Project Settings. This is a pretty important menu. Has a whole bunch of project settings that we can mess around with. You should explore this. You can even find our tags and layers is in here if you wanted to edit them that way. And there's one called physics. With physics, there's a bunch of the physics engine parameters that we can mess with. But you should also scroll down because this matrix down here, this physics layer interaction matrix, is the one that we want to mess around with. You'll see the layers that we've created, player and player projectile, aligned on these axes, and where they meet is an enabled collision. So do I want the player and other players to be able to run into each other? I could uncheck that box if not. Do I want player projectile and a player? Oh, that's the important one. I want to uncheck that box so projectiles and player don't interact. I could also disable collisions between projectiles and other projectiles. I don't know, sometimes it's fun to leave that on. All right, so that looks pretty good. And we should be able to then, with all that layer stuff set up, run this. Yeah, so now I don't get blasted around. The balls themselves, though, I mean, this is fun. I'm not gonna lie. There are some issues. They're still spawning within the player, which is fine, but I didn't tell them to move to the sides. I actually didn't tell them to move anywhere. So let's give them an initial velocity. When we instantiate an object like this, instantiate returns the game object. So let's catch that game object. I'll just abbreviate it GO for now. let's catch that game object, and then we can access the different components that are attached to that game object. I know that this is going to be my bullet, so it should have a rigid body component, and then I can use that rigid body component to give it an initial velocity. So let's say rigid body, I'll just call it RB, and I'm going to use the game object and get component. So get component is a function on every game object that allows us to access the first component of a specific type. So with these angle brackets, I'm going to specify what type of component I'm looking for, and it is a function call, so I've got the parentheses there. So I can get that rigid body component from the game object, which is our bullet. And then I need to check, just to be careful, make sure that our rigid body exists, that it actually had a rigid body component. If I swapped it out for a different prefab, this wouldn't be guaranteed. So it's probably good to do a null check here to make sure that we have a rigid body. And if we do, then we can set the velocity. All right, so we have to kind of decide what do we set this velocity to. We need some sort of like projectile speed. So we could say maybe this would be good to parameterize. So let's say bullet speed and then multiply by the direction that we want it to go. And there are several ways to get a direction we want it to go. We kind of want it to go relative to the player's perspective, this player object. We want it to go forward, right? So Unity is helpful here. We can use, like this is the player controller, so transform dot, and there is a forward vector that gives us a direction here. So we could do this, have some floating point bullet speed times the forward vector from the player will give us a velocity that goes in that direction at this speed. So let's put this as a serialized parameter here. Bullet speed, and I'm going to make it like 100 or something. That should be fine. All right, so yeah, that should set our velocity. We'll be good to go. Nice. I think maybe I'm still shooting them a little bit fast. All right, I also don't have the ability to turn at all. Let's see if we can fix that. So here I've gotten a direction for my motion. I might as well use that as a direction for turning as well. So I can do like transform dot rotation equals, and so I can set my rotation using this direction. Quaternion dot. Let's see what we can do with quaternions. So identity, we've talked about that one. It's no rotation. You can specify Euler angles, X, Y, and Z, depending on what you need to do with it. There's also this angle axis. This might be a good one for us. I can imagine that being useful. And some other things we can do. There is a look rotation, which is really handy. Look rotation allows you to choose a particular forward vector and an upward vector to make sure that your head stays upright, and point your rotation in that direction. So this one might actually be the easiest one for us to use here. We want a rotation that points in some direction. There's our normalized direction. And then upwards, we're going to say that this is just our positive y direction. So let's do vector 3 dot, and there are some built-in values here. Vector 3 dot up is the same thing as writing new vector 3 0 1 0. So having 1 in the y dimension. All right, that seems pretty good. So our rotation will be relative to whatever direction we're moving. Yeah. Okay. Yes, that's something. All right, and let's put some sort of object here that we can tell, like a wall. Let's call this wall. This one's not a wall. This is the goal zone. I'll just leave it the way it is. Okay, cool. So we can spray a ton of bullets at the wall. That's cool. There is something we have to be careful of. Let me get this camera zoomed out a little bit so we can see more of the action. All right, so in some games you may come across this issue. Let me see if I can make it happen here. All right. Some of those bullets are going right through. Do you see that? Why is that? Have you come across this in any games? Things going really fast and they just clip right through a wall or the floor sometimes. That's bad. I don't really want that to happen. But why is it happening?
With the rigid body being really slim compared to the size of the bullets.
Yeah, and the bullets are moving really fast. So if I was doing this a little more carefully, let me see. I don't think I can do it here. Let's do it like that. Yeah. So you can kind of see as I hold this that there are gaps between where I see the ball one frame and where I see it the next frame and so on. These balls are going a little bit too fast for me to really convince you that they're moving when you see them that way. But what it lets us kind of understand here is that these objects are just changing position and they're skipping over the wall. They're skipping right through it. They're never intersecting or colliding with the wall. That's just how the physics engine works. But there is an option we can set. So if you choose, let's see, the bullet, because that's the object that's moving, down in rigid body, we can change the collision detection mode from discrete to continuous. And so instead of just detecting if it overlaps something, it uses the two positions that it changed from one frame to the other, and does like a sweep between them, uses like a swept volume and compares that to the other colliders. So it's more expensive computationally, so don't do it on every object in the world, but it is really helpful for fast-moving objects. So that should solve our problem here. Yes, 0 bullets going through the wall. All right. We've also got an issue, I think, if you want to call it an issue, that these balls just hang out forever. You can see my hierarchy where all these bullets are, they still exist, even after they drop off the edge here. There they go into the abyss. And falling forever is like this permanent rain pouring over the side. Okay, well that's cool. It would be nice if my game didn't like start slowing down if the player just holds the shooting button. So I'd like the balls to be a little smarter. Maybe they can destroy themselves. So I don't have a script yet on the ball, right? The bullets. So let's make a new script. This will be the bullet. And then my bullet object, my prefab, I'm going to go down to the bottom and add component and look for bullet, that new script. And then open it up. So I don't need to do anything fancy here. I'm just going to use something that's built in and makes it easy for us. There is a function, destroy, that lets you destroy objects. And when you pass in a game object, this happens to be, this game object property is the bullet itself, the game object that contains this component. So if I call destroy on that game object, it's going to destroy itself immediately upon starting, which is a bad idea, right? We'll never even see the bullet. But there is an optional second parameter that will let you say, okay, well, maybe after 6 seconds, we'll actually destroy this object. So there's a delay parameter, which is pretty nice. Comes in handy quite often. All right, so just with that little change, throwing that bullet script onto our prefab, this should be a lot better. All right, so some of these rolling out to the edge should start disappearing. Cool, looks good. And then that also cleans up my hierarchy here over time as the balls get destroyed. Great. Okay, cool. Let's see. All right, I think that's pretty good. I want to show you where this stuff comes from. We've got horizontal and vertical and fire 1. There are other mappings for buttons and axes. And then I want to get into UI to make sure that we have time to go through all of that. So in the edit menu, if you go to project settings, there is an input manager category here. It does give me a couple of notices here because there's a new input system with recent versions of Unity that I'm not using. So I'm just going to expand the axes thing here. What this gives me is really just a list of all of the different mappings for the controls. You can see our friends horizontal and vertical here, fire 1, and you can expand these to see how their properties are set up. The name is horizontal, negative button, so whatever gives us a -1 is going to be the left arrow key, positive is the right arrow key. There's also an alternate. You can use A or you can use D, so A and D also work for this axis. And we can look at vertical. Fire 1 is the firing button we've been using. Mouse 0, I guess, is the left mouse button. There's also a left control, so you could be using the left control button instead. And then if you look further down, there's like a jump button that's mapped to the space bar. They're repetitive a little bit. There are additional bindings here for these controls. So like horizontal, let's expand that one. This is a different horizontal, but that's because it is mapped to a joystick axis. So if you like plugged in an Xbox controller, this is how you would do it. The joystick would just work. X and Y, the horizontal and vertical axes. And you can see down here, joystick button 0, whatever that means, is going to be your fire button. Okay, so that's where all of those magic strings come from, the names of these things. And you can change them if you want to, just by changing the name there. You can also add your own mappings. You have to change, this is pretty clunky, but you have to change the size of this list of axes to like 20 or something bigger than 18, and it will add more at the bottom that you can then change. All right, so that's where all that control stuff is done. Now let's talk a little bit about UI. So I'm going to go into, I'll do it here first. If you right-click in your hierarchy and you go to down to UI, gives you a bunch of different built-in widgets for a user interface. So one of those is panel. Let's just choose that one. A panel is kind of just like a window. And there it is, right? This makes sense. Let me zoom out. This makes a lot of sense. All right. Yeah, this is the panel I just created, and you'll notice on the left it's under a canvas object by default. They create a canvas and an event system object for you, so you don't have to worry about those. But all of our UI objects are going to go into a canvas so that they can be rendered. This one, this is pretty big. If you look at this, my 3D scene they've kind of been superimposed. We've got this 3D scene, we've also got this 2D graphic thing that's supposed to be overlaid. Let me try running this. Okay, it is overlaid over the entire screen. It's a little bit of a weird choice, but Unity does this. It puts them into the same view, and you can manipulate either one, the 3D scene or the 2D stuff, the UI. And it uses the same world units, but with different meaning. So we were talking about each unit being a meter in this 3D world. Well, in the 2D world, each unit is like a pixel. So this is the size of my viewport right here in pixels. So that's weird. But we'll live with it. If you click on the 2D button up here, this will shift you into an orthographic view where you can better view your two-dimensional stuff. And if you double click on the panel, it'll make sure that it's centered and facing the right way when you're looking at it. We want to switch over to the Rect tool. This is the tool you'll be using to modify and mess with UI elements. And we can select this panel and grab one of its blue corners and resize it if we want to. Let's make it a little smaller. Drag it to the center somewhere. All right. So on this panel, I'm going to put a score or something. Let's make this a little nicer. On the right in the inspector, you'll see the image component where we can select a new color. I don't know, maybe it needs to be orange. Brighter orange. It still looks pretty dark because it's on a blue background. And this thing happens to start off as kind of transparent. So let's change the alpha to fully opaque. That gives me a nicer orange. Okay. All right. And then we can, selecting that panel, and right-clicking on it, we can create other objects that are going to be children of the panel. So I'm going to go to UI and choose Text, Text Mesh Pro. So Text Mesh Pro used to be a plugin that was separate from Unity, but they've since absorbed it and has become an official part of the editor. But it is a better way to do text than we used to have. So since I'm using it for the first time, it wants me to import some things like fonts and stuff that are built in or should be built in. So I'll just do that and then I can close this panel. All right, so creating that text object, it's a child of the panel. And over on the side, I can type in whatever text I want, like score. And then I can modify this. Let's, actually I don't want to do that. There we go. All right, so depending on how it's arranged and everything, I might want to change things like the font size. Here, if I squeeze this down like this, it's not going to look so great. But I can change the font size, or I can press this auto size button to make it fit into that spot, and change the color if I want to. And then also the alignment. Make sure that's centered in that box. That's the way I usually like it. And then we can add some other text in here. Let's right-click on the panel and add more text. And this is the one that's actually going to be having our score value. So I'll do the same things, auto size, let me align it. That looks fine. Maybe over here, maybe there. Okay, that's good. All right, so we've got our score. This is the score value. And this is our score label. Cool. Now, one thing that's going to happen here that is a little bit annoying, but it makes sense, is that I'm working now within this viewport, which is not always going to be the shape of my screen, whoever's playing my game. And so even like changing this viewport, check this out. I'm going to swap over to the game view to give it a chance to update. And back to scene. What it's done is changed my canvas size to fit this new viewport, and the panel within it also changed size, and it looks like it's all messed up. So let me get this back to roughly the shape it was. I could go back to default. Okay. So switching this back, all right, it's back to the way it was. But with UI, you do need to take care of anchors and how these, the anchors control how these objects scale when the screen around them changes shape. So you might be on like a mobile phone or something, or a screen that has a high resolution, or you might be using it in the editor and you want your UI to still be readable and usable no matter which screen you're using. So these anchors are how you do it. With the panel here up at the top, I kind of want it to stay up at the top and maybe even stay this size. So I can grab these anchor points here, drag them up here, and there we go. This is the anchor point, and all of the positions of the corners of this panel are relative to that point now. So if my canvas ever changes, here I can do a quick preview of what that would look like. It's going to stay in the middle. And here, if my screen were narrower or wider, whatever that is, it's still going to stick to the top. You should do this for all of your UI elements, but I'm going to save time right now and just skip the rest of it. Okay, so let's get onto that score. For one, we're going to have to figure out a place where the score should live. It's got to be some sort of variable. It's going to start at 0. I'm just going to make it an integer. It has to have a place where the variable exists. We need to be able to access that and update what is being shown on the screen here. All right, so one place that could go, like one typical thing that we do is we have an object that does not get destroyed between scene changes, and so it'll persist and we can store data there that the player needs to use. And that's a really good way to do it. In Unity, that's commonly done using a Singleton pattern, which isn't always the best solution for all software, but in Unity it's very useful. So we would have one object that's like the game controller or game manager that is in charge of keeping track of the score and deciding when you move to the next level and all that stuff, right? That might be something that it does. That's one way to do it, and that's the preferred way, but I don't think I have time to get into doing that and covering all the other stuff. But you can look into that. What I will do here instead is say, all right, when is my score increasing? And maybe it's when some object gets hit or when I shoot projectiles or something. Let's say whenever a projectile gets destroyed, that would be a pretty bad way to do it, but I'll do it that way anyway. Let me think. That might not work. Oh, I know. How about the goal zone? Yeah. So we can score in the goal zone. That makes sense. Okay, so our friend goal zone here is waiting for this ball to enter, and in our goal script would be a fine place to say, all right, here is a score that starts at 0. And if I want to be able to modify the text on the screen, I also need a reference to that text. So for the Text Mesh Pro stuff, I need to add another using statement, TM Pro at the top of my file here. And then I have access to this. Let's make another reference. Text Mesh Pro UGUI. So that's going to be our score text. So we'll hook up that reference in the editor, and whenever we score, we'll say, okay, score plus plus, and then this we're actually doing. Make something the player can see. We can do score text dot text equals, let's do just score dot toString. Okay, so our text object now has a string that we can reassign, and we're going to take our integer and just convert it to a string and use that as what's going to show up there. So now every time that the ball enters this goal zone, it should increment our score and show that to the player in some form. All right, so selecting our goal zone, we still have not set up this reference score text. So let me grab score value as that text object, drop it in there, and then I think we're good to try it out. Got to somehow get the ball into the goal zone. How about I shoot it? That didn't work. Too fast. All right, I'll be patient. Get to the goal. Go. Nice. All right. Good. We got a score. Awesome. Okay. So there may be a couple of other things we should talk about. This is really good so far. I think what I'd like to do with our remaining time, I want to show you something about the Nav Mesh system in Unity, where we can set up AI agents to move around on a navigation mesh. It's pretty quick because Unity has that stuff built in to do some simple AI. And then I think we should try to do like a title screen or something to do a scene transition when you click a button. Try to do that as well as we can in 20 minutes. You with me? We ready for this? Okay. So let's create an AI agent. Let's say right-click in here, and we really could use like one of those dudes that runs around. But let's just do a 3D object, a capsule, so it'll stand out. This is my bad guy. All right, bad guy. Capsules are 2 meters tall, so just like a humanoid. And so I'm giving it a y coordinate of 1, if that matters. And this is going to be like an enemy soccer player or something. Let's do this. Move him back off a little bit, and I'm going to make a new script for him. All right, bad guy. Yeah, I have to wait until this thing rebuilds. Okay, bad guy. So bad guy is going to be using a special component. Let's add component Nav Mesh Agent. There we go. So a Nav Mesh Agent is capable of doing pathfinding and moving objects. So it'll move this, this guy. And what it needs, though, is a nav mesh, a navigation mesh, to tell it what are the allowable areas that it can move on. So to set that up, let's go to Window. There is an AI category here, and let's go to Navigation. So in the Navigation panel, it pops up over here next to my inspector. We can select objects. So say we select, let's do this. Select the ground here and make that navigation static. That allows us to say whether it's walkable or not. Let me also select the wall here. Let's make that static, but make it not walkable. And then we should be able to go to bake. And so these are parameters of the agents and the distances that they're going to be told to stay away from things. But let's just press bake, let that do its default stuff. And you can see that it's created a blue area here now. It is a mesh. You can kind of see some of those things coming off. And you can see where it's standing off from the wall that we had set as an obstacle there. And it's staying away from the edges of this this plane as well. So now this is like an allowable region for the AI to navigate. Whenever it path finds, if it were trying to find a path on the other side of this wall, it would have to navigate around that wall. It can't go through that area. But for the goal zone, it can just plow right through. All right, that seems pretty good. So our bad guy, what I would like them to do, let me hop over back to the inspector. I'd like the bad guy to chase the ball. So the ball is kind of going to be its target, its destination. Wherever the ball's position is, that's where he wants to go. So I'm going to add another script for the bad guy. Oh, I do have that script. So let me open up the bad guy script. For bad guy, I want to have a reference to the ball. So let's say serialize field. Let's just call it the target. So that's going to be the ball. And we'll fill that in the editor. We also want to have a reference to the Nav Mesh Agent component because we'll be using it every frame to tell it, go here, now go over there, because the ball just moved. So we're going to want something like a Nav Mesh Agent. I don't have access to this type, so I need to include or add a using statement. UnityEngine.ai. Now this should let me get it. So Nav Mesh Agent, let's just call this agent. So this one, we need to fill this in by getting that component. So agent equals get component Nav Mesh Agent. All right. And then in our update, we can say every frame agent.setDestination, and we can tell it to go somewhere. And that somewhere is going to be taken from this target object. Target dot, and every object has a transform component. So we can just say go to that position. All right, so pretty simple, just a few lines here. And this does all the magic. Setting that destination to be the position of the ball. So back in Unity, I want to make sure I get that reference to the ball set up. Once this builds, we should see that new property. Here we go, target. So I'll grab the ball and toss it into the target slot there. And I think we're ready to go. Let's try that out. There he goes. Oh, is he gonna? No. He doesn't want to go score. Oh, he's on top of the ball. The ball is like under him. So he's not doing proper collisions with physical objects. So I should give him add component. Let's do a rigid body component for him. And so sometimes just like a dynamic rigid body doesn't work that well with the AI system, with this Nav Mesh agent. They kind of fight for control, like is the velocity moving the object or is the Nav Mesh agent moving the object? So we want to check this is kinematic box to tell it that don't use the velocity, don't get pushed around. It kind of gives him like infinite mass, which is going to be fun, but let's try that. Gravity I don't think matters anymore. This should allow the bad guy to, yeah, there we go. No, stealing it. No, oh, he scored. Okay. He's going to go push the ball off the edge, I think. All right, and so now, since we have all that set up for the bad guy, we can even make a prefab of the bad guy. Let me see. When we drop in a new bad guy, we probably still have to set the target to be the ball. Yep, get him out of the ground. All right, but now we have as many bad guys as we want, and they'll chase the ball and fight over it, I guess. Cool. All right, so that's how the Nav Mesh system works on just a quick basic level. Let's get on to talking about a title screen, and yeah, I think we can do this. So when you go to File, you can make a new scene. Let's do. Yeah, it doesn't really matter. Let's do just a basic built-in one, and we'll create that scene. It brings us over to a new scene, and immediately I'm going to save this scene so that I can give it a name. I'm going to place it in the Scenes folder, and let's call this Title Screen. All right, so we can find that in our Scenes folder now in our assets, and we can swap back and forth between sample scene where we were doing our work and title screen. So in title screen, I just want to create some UI. Let's do a panel. On that panel, let's do a button. There we go. There's the button. And then if you expand the button, you'll see that it has a text sub-object that is saying button. And you can make it say whatever you want. Seems pretty good. All right. So I'll leave like messing with handles and everything up to you. But when I select Start Button, I can go down to the button component that's on the button object. And down at the bottom, it has an on-click field here, a list of actions to do when you click on it. So if I press plus here, it gives me the option to choose an object that's going to receive this action, that's going to perform this action. And then I can call a public function. It has to be a pretty simple function, the way that this is set up for Unity. To activate when this click happens. So I'm just going to make a script so that I can say, all right, let's create a new script. Let's just call this title screen manager or something. And I'll make an empty object in this title screen. And the only responsibility for this object, it doesn't have to render anything. It doesn't need any particular position. It's really just a holder for this behavior, this script. So there's my title screen manager. Drop that script on there, and then I can give this object some behavior. Did I? This renders weird. It's a capital I, that's why. All right, I'll leave it the way it is, but it's a typo. All right, so I want to just throw in a public function, something that the button can access, and let's just call it start game. So in order to switch scenes, we do need access to a different part of the Unity Engine API. So Unity Engine.scene management. And then when I try to start the game, all I need to do is scene manager dot load scene. So load scene takes either a scene build index, a number, or a string that's referring to the name of the scene. Here, I'm just going to say, what was my other one called? Like sample scene? I think that's what it was called. So I'll try that, see how that goes. And that's all I need for making that script work. It is attached to my title screen manager object, and then the button has to call that function. So in the button component, on click, I added one of these actions. I'm going to choose the title screen manager as the object that we're using. And then the function is going to be one of the title screen manager functions called start game. So there it is. Let's see, does this work? Oh, it won't work. So one last thing I need to do. In File, there is a Build Settings menu. And here, we have to list the scenes that are going to be part of our actual shipping game. I can press Add Open Scenes. It adds the title screen. That's our first scene. I can also go through and grab the sample scene and drop it into this list. So I have now sample scene in my build. And I don't need to build it right now. I just need those scenes in the list so that it knows they can be referred to by the scene manager. So now I should be able to press play and click on that button. Yeah, nice. There we go. It's crazy soccer. All right, we got there. We got there. Excellent. So I think that's everything we need to do right now. There are a few things. Of course, there's always more that we can do, more that we can talk about, and I do it all day, every day. So I guess that's enough. Thank you guys for following along, for your patience, and hopefully that was helpful to you and should help you along the way with your projects. Yeah, come visit sometime. We have our Inkwell studio in the bottom floor of Robert Frost. You can come have a tour of it. If you take one of our game courses, some of our game studio courses end up in the studio and doing projects for clients, companies outside of SNU, sometimes professors at SNU want us to make a game for them. So a lot of cool stuff we're doing there.
Sounds great. Thank you very much. Appreciate it.
Thank you.